All right, so here is our objective. All right, here's the point of the video. And the best way I want, or the way I want to show you why I'm doing or how this works is to start with some examples for chromatography. I have 3 pens and I drew lines with them. The fourth was a pen that didn't work. And as you look closer at these ink things, lines, you might have a question. Hey, which ink came from which pen? And chromatography would allow you to answer that question. All right. Now you might look at another example. If you're looking at this blood pressure reading from a doctor, you might notice something here that looks a wee bit suspicious. And you might be asking yourself, hey, how did I get here? It's a reference to a Talking Heads song, really good song. But this might be the question you're asking. And if you look, this looks very suspicious. And chromatography would give you proof that these inks came from different pens. All right. Now, before we move forward, this is a good working definition for what it is. Essentially, it's a technique used in lab. All right. And that's its purpose. This is what you want to do with it. Now, I want to when you talk about the different types of chromatography, they all have the same purpose. But Dr. Erika Kremer from Prague, who was born in 1927, April 27th, was one of the first people who came up with the ideas for gas chromatography and pioneered it in the late 40s and early 50s. And this is like an example of what she did, her gas chromatography. And this is a lot to take in, but essentially you're moving gas through something and it's moving your sample through something and you're hoping to separate them out. All right. This is this is paper chromatography. And here you can see we're separating some dyes. And this is another type of chromatography called liquid chromatography. And where you've got a gel and you're moving a liquid through it by gravity or force. Now, in all of these things, in all of these chromatography types, the goal is the same. You're starting with something that's all mixed up, and your goal is to separate it into its components. You might be doing this to identify what you've got, like with the ink. Are they the same ink? All right. You might be doing it to say how much of one component you have as compared to another, like to quantify it, or you might be trying to purify it, like take one component out. And that's why we would do this. Now, the reason I bring up the types, because this being a modern day gas chromatographer, it looks kind of like a mass spectrometry. All right, this big machine that separates and looks things into categories. And this paper chromatography setup and this liquid chromatography setup, all of them follow the same general setup. In that they're set up with the same pieces, but they just look a little different and have each of the components has a different part or different type, as we'll see in a moment. All right, here is the basic setup of your chromatography. You're going to have a column where you find your stationary phase, and you're going to have a sample and mobile phase that move through this column, and all that together, they separate the sample. So the stationary phase and the mobile phase within the column separate your sample into its components. Now, I would like to start with, I would like to give you just a little detail about the 4 pieces of chromatography. The first being the sample. In this case, the sample is the dye, all right? And the sample is essentially what you're trying to break up into its components. The black dye into its various colors, or the gas into its different pieces of gas. And with liquid chromatography, or paper chromatography or thin plate chromatography. This is paper chromatography. Um, it's often a solution or a dried solution, all right? And in gas, it's gas. Now, the next thing I'd like to talk about is the column. The column pertains mostly to liquid chromatography, where you're forcing a liquid through like a gel by either by pressure or by gravity. And this is where you're separating it, all right? And this is what holds your stationary phase. All right, in this case, it's a gel. The column in the paper, it isn't really a column, but it is in a sense. But it has the same. It is the stationary phase, and it is where the separation occurs. All right, but you'd hold the term column mainly goes with your liquid chromatography. Now, the mobile phase is what you're going to move through your column or your stationary phase, and it can be various phases. They have to be fluids, and if it's liquid chromatography, it's often referred to as your solvent. And in gas chromatography, your mobile phase is often an inert gas like nitrogen gas. Please write that down. All right. And finally, our stationary phase is what's staying put and what the mobile phase is moving through to separate your column. It's often a, a semi-polar substance. And in this case, we're talking about these three compounds, all right? And there are like I should say these are like three mixtures because you're going to have various compounds in them. All right. Thank you, and let me know if this helps, and let me know if you have any questions.